happens is that the very first step that we take is that we look at what is a domain modeling and what is the goal of design and through which levels of abstraction does the system pass. So the goal of design is the division of the system into manageable units, the coarse granular design, architecture in the narrower sense, and fine granular design. So then we have requirements design exists at 4 abstraction levels refined by step, the context level and the domain level, determine and model design. So domain level splits into use cases, user stories, scenarios, and domain data, dictionary of terms, data model. Then interaction level and system level, what happens in between. This is the granular refinement, different views. Then we have coding, which is implement design. Then we have example for the online conference system that the domain level fixes entities, meetings, participant before any UI and or storage decisions are made. Then we have what is domain data. Domain data describes entities, things, and concepts. These are things and concepts that are important in the context. They explain the terms used in the client's description, are usually described by simple case diagrams like domain case diagrams. Attributes and operations do not need to be fully captured at this stage. Cardinalities and relationships are important at this stage. Glossary often also sufficient or supplementary. The goal is to understand the basic entities of the real world and their relationships that are necessary to understand the tasks at hand. So domain data is high level of abstraction. It describes data relevant to the system. Not yet a full database schema or attributes operations may be incomplete, but cardinalities and relationships are very important. How do you identify domain data? Linguistic analysis. When we do linguistic analysis for the identification of data, which nouns have been used in the description so far, for example. Which of the nouns are synonymous? We eliminate them and decide only one term. Record your decision in the dictionary as a synonym that should not be used again. Now, concretize, specify vague terms, too general or too specific. For example, Peter Winter should be able to use the online conference system alongside other people at the TH Aschaffenburg. The system should work via SSO. Candidate, noun, online conference system. So here candidate, now nouns are online conference system, people system. So we have people, we have online conference system, we have a system. Then we know that these are nouns. Then what we can do is that once we know that we have nouns, we can then look at in the description what is an association and what do reading direction, navigation direction, and cardinality mean. Associations are between classes, model possibly object relationships between the class instances. For example, association name labels the relationship take part of. Reading direction shows how to read the name. This is not the navigation direction. Navigation direction shows which side can reach the other. So this is the navigation. Which side can reach which direction, like this direction goes there, this goes there. Then we have cardinality, number of objects that can be related to exactly one object on the opposite side. For example, meeting takes place with one or many participants. This is cardinality. Reading direction is not equal to navigation direction. The professor stresses this, not navigation direction. It's a classical trap. So reading direction is not the same as navigation direction. So you might also read from here to here, but it's not the navigation direction. How to read the name. This is not the navigation direction. It's not that it navigates to this part. What navigability variants does UML allow? UML allow association, navigability, navigability. Happens is that because we know that the reading direction is nevertheless not equal to the navigation direction. This is pretty much obvious now. The professor also stresses this, that the reading direction is not that the same as the navigation. Navigation is something different. You navigate here, but you're reading from here to there. It's different things. So association, navigability, UML is allowed. So UML association direction is not yet defined. In practice, this is often treated as equivalent to bidirectional, which is case 2, if not defined. Bidirectional navigability, arrow both ends. So arrow on both ends, arrows on both ends like this. UML standard direction not yet defined. So it's a plain line, no direction yet defined. So this goes to this, for example, arrow left to right. Unidirectional navigability, from left to right not defined with other direction. Arrows navigate from left to right, this one, arrow navigate from left to right, but reverse navigation is not possible. So reverse navigation is not possible then. How are cardinalities noted in UML? Exactly one, more than one, more than zero, so many or zero, too many, 0 or 1, meaning notation is 0 to 1, 0 or 1, or 0 comma 1. Fixed range, like 3, example 3. Range 3 to many, for example, or 3 to 6, this is also range. Then we have enumerical, like 3, 6, 7, 8, like exactly numerical, or certain numbers that 3, 6, up to 9. Owner, a car can have 0 to many. So owner 1 to so owner and car relationship is 1 to this side, 0 to many. A car has exactly one owner. An owner can own none or several cars. So a owner can own 0 or many cars. So company, 0 to employee. So company to employee relationship is a plain line. It says that a company can have 0 to many employees, or so at least one employee works in a company, at least. So this is least, this is max, least to max. So at least 1 to many employees can work in a company, because if there is no employee, then there is no company. So persons with roles child to many and parent to. So what is aggregation, and what properties does it have? Special form of association is part of. Now this reflexive is person with roles, for example, child, 0 to many, and parents too. So a child only has 2 parents, but can have 0 children or many children. Then we have special form of association. Aggregation, what are the properties does it have? Is a special form, or is part of relationship. There is a superordinate whole that contains a subcoordinate whole. UML distinguishes this in 2 types: weak aggregation, shared aggregation, and strong aggregation, composition. So composite aggregation. Strong aggregation is composition, which is composite aggregation. So it has the properties of transitivity. If C is part of B and B is part of A, if C is part of B and B is part of A, then C is also part of A. Of course, it's very much obvious. If cooling system is part of engine and the engine is part of the car, then the cooling system is also part of the car, of course. So if cooling system is part of the engine, so it's a smaller thing. This is part of this is cooler system, this is engine, and this is the car. So engine is part of the car, then of course this is also part of the car. Anti-symmetric. If B is part of A, then A cannot part of B. So if engine is part of car, the car cannot be part of engine. So engine is part of the car is not inside the engine. So it's not that the car is inside this engine. What is weak aggregation? So part independent of whole. Hollow diamond, whole side is weak aggregation, which is not filled yet. So weak aggregation means that this thing can exist on its own independently. Without an engine, there is no car. So if you remove the engine is a strong aggregation. It cannot stay without a car. So it's a composite aggregation. Cardinality can be more than one. The parts also exist without the whole, or if the whole is deleted, the parts can still exist. So document has a weak aggregation to text. So it's not dependent on, so if you remove it, this is weak aggregation. So if you remove the text and the graphic, the document still exists. So you make a new blank document and you add the text. So this is text, the relationship text has to the document is of a weak. So if you remove this text, you basically can still keep the document. What is a strong aggregation composition? It's a fill with composition with the diamond that is filled, just like we said, the diamond is filled here. On whole side, a part can only be part of one whole at any given time, cardinality max 1, 0 to 1. If the whole system is deleted, the parts are also deleted. So if you cardinality 1 also appears in the literature, existence dependency, the part cannot exist without the whole. So comment has 0 to many, strong aggregation to document. So for example, if you have a document and you make a comment in that document, then if you delete that comment, which text, module, and graphic. So a document can have 0 to, one document can have 0 to many comments, but if you delete those comments, then these comments purely depend on this. Oh, so we basically learn is that comment to document is a weak aggregation. If you delete the document, the comments can still exist independently, like users' comment history. They are loosely associated. But document to text is a strong composition. If you delete the document, the text inside it is also destroyed. So if you just get rid, so the rule is that if deleting the parent kills the child, it's strong. If child survive, it's weak. So we know that if we delete the document, there is no text. So we know that text has a weak aggregation to the document. It cannot exist independently, but comments can exist independently than the document. If you remove the document, then you can still go and see the comment history, and then you would know that it's strongly dependent on it. It cannot exist independently, just like doors cannot exist without in a cupboard. If you have a cupboard, doors cannot exist without the cupboard. So they are strongly aggregated, they're strongly connected, like a motherboard is strongly aggregated to a mobile. How do you distinguish between strong and weak aggregation? There are three key things. Visibility, is part only visible to the whole? Answer is yes. Strong composition, yes. Weak composition, no. Its part is not only visible to the whole. Lifetime, does the part exist when the whole is deleted? No, the whole creates and deletes the part as well. In weak, yes, it still exists. Copy, what happens when a whole is copied? So I hope you also got this point for the comment thing, but anyways, we need to go further into the visibility things. That is part only visible whole? Yes. In a strong composition, yes. In weak, no. Is part only visible to the whole? Yes. In strong, yes, it's visible to the whole. In weak, no, it's not visible to the whole. And then we have lifetime. Does the part exist when the whole is deleted? No, the whole creates and deletes the part. In weak, yes, it exists. Copy, what happens when the whole is copied? The whole and the parts are copied in strong composition. In weak composition, only reference to the parts are copied. So aggregation example are car tires. Which relationships are correct? So if we have car and we give this relationship, this notation, 0 to 1 and 4 in tires, a car has exactly 4 tires. 4 tires are mounted to 0 or 1 car at one time. So minimum 0 cars or 1 car. This is correct. Then we have second strong aggregation saying that 1 to 4 tires. 4 tires are mounted on exactly 1 car at a time. This is incorrect because tires do not have to be mounted. You don't have to mount any cars. You can give the option of 0 mounting as well. You don't have to mount them. It's not a must. 4 tires are mounted to any number of cars at any one time. This is completely wrong. So, but a car has 1 to 2 tire types. A tire type can be mounted to any car. Same types must be on the axles. This is weak aggregation to tire type. This is completely wrong because tires cannot exist independently without the car. If there are no tires, then there is no car. So tires need car to exist or to make sense. What are the 5 relationship types between classes in UML? We have generalization, we have implementation, we have association, we have aggregation weak and aggregation strong. Then we have meanings, parent, subclass, inherits is a relationship, interface, class, implement behavior, for example. And then we have for parent, for generalization, the symbol is hollow. It's like this, and it's a solid line. Then we have implementation in interface class implemented behavior. It's hollow again, and a dashed line like this dashed. Then we have association. Class A associated class B has a relationship. It's associated with this. It's just a plain line. Then we have aggregation, that is like this. And then we have this filled. These are the different types that we have. Then we have class diagram error exercise. What mistakes should you spot? So the name is not class variable and attribute wrongly shown as static. So the name of the class should be changed. This is illegal. It's weird. The class is defined twice. So the meal was defined twice. The wrong direction of generalization. Cook employee inheritance arrow reversed. So this is also not right. Incorrect cardinality for the composition. These 5 reoccur in exam class diagrams: illegal names, static versus instance confusion, duplicate classes, and reverse generalization arrows, and impossible composition cardinalities. To go context and domain level, understand the context of users when designing the UX, product vision and goals, user stories, tasks and use cases, domain data, roles and personas characterize this context. This ensures the right tasks are supported without introducing technical considerations too early. And then domain data describes real-world entities and their relationship. A simplified UML class can represent them graphically. Then we have part B, which is architecture and introduction. How do IEEE standards define design and architecture? So design is the process of defining the architecture, components, interfaces, and other characteristics of a system or component. The result of the process in IEEE STD 610.12.19.1920. Then we have architecture, the fundamental organization of a system embodied in its components, their relationship to each other and to the environment, and the principles guiding its design and evolution. Architecture describes the result. Design describes both the activity and the result. So exam probe could be distinguish the two. Architecture equals to result versus design equals to activity plus result. So we need to cite the IEEE standard numbers if asked. Then what is a component? A component is part of a system. The architecture determines which components a system should consist of. A component is atomic or more refined. It offers its environment a set of services usable via a well-defined interface. So and then we have a definition. A software component is a unit of composition with contractually specified interfaces and explicit content dependencies. It can be deployed independently and is subject to composition by third parties. And then we have a warning that components are for composition. Much beyond that is unknown. Then we have in which direction can the design process proceed. An iterative process that encompasses all directions, access, tasks, problems, system, software, hardware, system level, user interface, interaction level, top to down, step-by-step refinement, top to down, bottom to up, reverse engineering, bottom up development, outside in from the user interface inward, inside out from the core outward. These are different directions can the design process. How do you derive a good software architecture? In general, an architecture is good if the functional and non-functional requirements can be fulfilled. No design method guarantees a good architecture, but proven design principles and design patterns help answer among others. What criteria should be used to divide the system into components? Which aspects should be summarized in components? Which services should components offer to the outside world at their interface, and how aspects must be protected? How should the components interact with each other? How should components be structured and refined? These are the things that we need to know. Then we have architecture quality trade-off, security and versus usability, reliability and maintainability. Then we know how do architecture decisions relate to quality. Architecture decisions have an enormous influence on the quality characteristics of a software system. Quality features influence each other. There is no perfect architecture that fulfills all quality features equally, but prioritization of the quality detail is very important. We have trade-off examples, security versus usability. So use of multiple authentication levels increases security, of course, like a two-factor authentication and many other things that you can add, but affects usability. Users use weak passwords they can remember, do not log out, reuse the same passwords, etc. For example, nested protection. Application authentication is a set of feature authentication, a set of encryption, a set of protected goals, example of a database. What we understand is that the more you make it secure, the difficult it might be for users to use it. Then what we know is that trade-off example is reliability versus maintainability, availability of percentage of the time the system is available. A system that should be available 99% of the time, available 86,313 out of 86,400 seconds a day, achieved very high redundant systems. For example, online banking with all disadvantages of duplicate maintenance and cost. So know the concrete number, 99.9% availability is almost 86,313 out of 86,400 millisecond, which is almost 87 seconds downtime per day. Redundancy buys reliability at the cost of maintainability. So if there is redundancy, then it buys us reliability at the cost of maintainability. So we have highly redundant systems, multiple servers. Basically, if one goes down, the other one is available. It's redundant. It's the same copy of the same thing and multiple backups, and that's why it's up all of the time. And when it's up all of the time, it buys us reliability, but that's cost of maintenance. It's difficult to maintain. Then architecture complexity. We have coupling and cohesion, reduction principles, hierarchies, and layered architectures. How do coupling and cohesion reduce complexity? We have analog of a concert hall. Architecture builds the hall so that the acoustic disturbance from the outside is extremely low and audibility inside is extremely high. In software, this maps to dividing into modules so that the coupling, width, and the complexity of interface between the modules is minimized. The cohesion relationship between the parts of a module is as high as possible. So the exam mantra is that low coupling and high cohesion. Coupling equals to between modules. Cohesion is within a module. So coupling is between modules. Between two modules is couple, and cohesion is within a module. So coupling within width and complexity of interfaces between, so how complex they are connected together, is minimized. And cohesion is a relationship between the parts of a module. So how they are relationship between parts, this part relationship with this part within of a module is as high as possible. So they are as tightly packed as possible. They are with one module on its own is tightly packed, and the way it's connected to other is highly close. Which properties reduce complexity? Separation of concerns, combine related architectural concerns responsibilities into groups of related functions, authentication, database management, system monitoring, single responsibility principle. A component is responsible only for one task, not that one component is doing everything. Don't repeat yourself. Dry. Do not duplicate. Any functional duplication makes maintenance even more difficult. So ensure stability. Small interfaces. Changes to interfaces mean all components that implement the interface may have to change. So ensure small, stable interfaces. Changes to interfaces mean all components that implement the interface may have to change. Then we have which hierarchical structure helps reduce complexity. A hierarchy is a structure of elements ranked by hierarchy forming relationship, a proven method for reducing complexity. We have hierarchy. Aggregation hierarchy is organized by systems into its components. Whole part hierarchy, which is the relationship consists of. Then we have a layered hierarchy. Layers, each layers one layer below and being the basis for exactly one above, and relationship is based on. Then we have generalization hierarchy, combining common characteristics into one universal component. Specialized components inherit and add special features. It is defined only once, and the relationship is specification of. Then we have example of object-oriented design, focuses on generalization hierarchies of classes and interfaces. This example is from Ludwig 2013. Then we know that describing the general layered architecture for web-based applications. We have 5 layers top to bottom. We have browser layer, mobile interface layer. This is the layered architecture. We have web browser interfaces, JavaScript components for local action. Example, input validation. This is the responsibility of this browser-based mobile interface layer. We have authentication and UI management layer. Management layer is for user interface components for authentication, creation of web pages, etc. Then we have application specific functionality application layer. This is where business logic takes place on the application layer. Then we have common basic services layer, reuse of basic functionalities required by the application layer. Then we have this is database management, transaction and database management. Database layer providing services such as transaction management and recovery. So for banking example, input validation amount, this is the top, authentication and page structure transferring, money balance, standing orders, customer account, and then persistence. This is how it goes. Then we have what rules govern layers and strict layering. A layer combines components that logically belong together. This is what a layer does. A layer provides services offered as its upper interface. If strictly layered, the services of a layer can only be used by components of the layer directly above it. Access to several layers is not permitted. Then we have changes in a layer should only affect the layers above it, not below. So if there's a change in a layer, for example, if you make a change in this layer, there are multiple layers one after the other. So if it says that changes in layer should only affect the layers above it. So if we make a change here, it should only affect this one, not this one, because there might be multiple down. Layers are only coupled if adjacent. Coupling is low due to encapsulation. So changes usually have only a local effect within one layer. So this is why it's so easy to go back to that layer specifically, because it has a specific job and then just fix it. Then what are cross-cutting concerns, CCC? Some responsibilities are cross-cutting and must be considered in each layer. For example, cross-cutting concerns security, performance, reliability. So the typical quality feature are CCC. Example, security attacks can happen at any level. Protection mechanisms must be implemented at every level. Then we have what is the 3-layer architecture. Many interactive systems consist of 3 layers: presentation layer, application layer, data storage layer. So presentation layer is implementation of UI, display information, controls the user system interaction. Then we have application layer, all components that implement the technical functionality designed so they contain no information about the presentation. Then we have data storage layer. Ensures permanent storage, usually in a database. Storage details are hidden in this layer, so we don't really know the storage details in this one. Then we have further principles like KISS and abstraction. KISS is keep it simple and stupid. Originally keep it short and simple. But keep it short and simple is a little difficult to memorize. That's why they said it like this. Then we have abstraction, the basis of many design principles. By creating abstraction, we concentrate on the essentials and ignore the non-essentials, basically. Then we have what is the open-close principle. Open for expansion but close for change. Extension can be made without having to change existing code. We made something. Now it's not that we have to make it again. We just need to expand it. We just need to add new features to it. And so, for example, supporting constructs inheritance, subclassing, and interfacing, polymorphisms. A stable base type stays closed while new subclasses stay open. Then we have patterns. For example, architecture pattern versus design pattern. Architecture patterns are solution for non-trivial problems at the level of the coarse layer, at the level of coarse granular layer. Architecture in narrower sense of components. Example, layer architecture, client server architecture, MVC, model view control. Then we have design pattern, solutions for non-trivial problems at the level of detailed component design. Then we say both are formulated independently of a specific language, but are usually based on object-oriented concepts. These are the architecture pattern versus design patterns. And what are the advantages of design patterns and the warnings? Now let us use our experience and implement tried and tested solutions. It helps us consider non-functional design, maintainability, reusability in the architectural design, creates a vocabulary for the design and facilitate documentation and communication about architectures. It can be used as an analysis tool when re-engineering existing software that you already have. So understanding a design pattern is easy, but you need a lot of design experience to use the patterns sensibly. Then we have what is a library and what is a framework. A library is a class of library consists of sets of classes that are reusable, offer generally usable functionality. Example is that independent of the application context. From the application's point of view, library classes are used directly or application classes inherent from them. So a framework is an architecture of a class hierarchies that provides a general generic solution for similar problems in a specific context. For repeatedly developed similar applications built on a generic solution, a framework has defined interfaces at which the generic solution can be extended with application-specific core UI frameworks, test frameworks,
or frameworks rely heavily on the inversion of control principle. Then we have library versus framework. Who calls whom? Your code calls the library and the framework calls your code. So then we have how is architectural quality safeguarded. The quality of the architecture significantly determines the quality of and the cost of developed systems, and does so in the long term. Therefore, prioritize quality requirements, carry out architectural reviews, evaluate the extent to which the quality requirements are met, and document the why of an architectural decision. Then we have what does object-oriented analysis and design involve. It involves finding functional units and designing classes so that they represent the relevant units and concepts of the application area, the part of reality to be modeled. And then we have central activities of OO design. Object-oriented design, we have identifying objects and classes, we have defining the behavior of objects and classes, identifying relationships between the classes, defining the interfaces between the classes. The design is based on the object-oriented current state analysis, which aims to identify technical processes and model them as use cases, and to describe the units using an object-oriented conceptual model. Then we have exercise questions with model answers. Why minimize the complexity of a system? So when we lower complexity means lower coupling and high cohesion. Easier to understand basically. Maintain, test, and change. Change, stay local, fewer defects, and then we have lower term cost. Then we have centralized versus distributed security model. Now what advantage? One disadvantage for each. For centralized, all sensitive info in one place. Advantage, we have easier to protect, monitor, and audit a single point. Disadvantage is that single point of failure or attack, one breach exposes everything. This is centralized system, this centralized model, all sensitive info in one place. Then we have distributed, info spread in many places. The distributed security model, a breach expose only part, no single part of failure. And then the disadvantage, this is advantage that a breach exposes only a single part, no single point of failure. Disadvantage is that larger attack surface, harder to secure, monitor, and keep consistent. Then we have what is the separation of concerns principle. Combine related concern responsibility into group or related functions and keep unrelated ones apart. So each component is responsible for only one task, single responsibility, for example, reducing coupling and complexity. Then after that, we can go ahead and look at our UML models, class diagrams with cardinalities. We can say association, reading directions, and name. For example, the meeting. Draw meeting and participant, we know these are entities, joined by an association named take part, and add the reading direction triangle and label cardinality. A meeting has one or many participants. A participant takes part in only one meeting here. So we know that we have a meeting and we have association here. This is not a navigation direction. This is a reading direction, for example. Association name plus reading direction triangle. This is not a navigation triangle. So it's not that it's navigating, it's just helping us to read. So participant takes part in the meeting. So it takes part here. So a participant, so a meeting can, in one meeting, there could be one or many participants, and one or many participants should have at least one meeting. So meeting association, meeting one, and the end we have participant one to many. So we know that participant joined by an association, a participant takes part in exactly one meeting. So a participant can, with zero participant there is no meeting. There needs to be at least one participant. A meeting can have one to many participants, and there is one meeting going here. There's draw meeting joined by association takes part. So meeting takes part with one or up to many participants. Then we have draw company and employee. We have company entity, we have employee entity with role names on each end. At least one employee works in a company, and employee may work in several companies. So employee can, with roles, at least one employee works in a company. So at least one employee works in a company, one to many, and then a company can have 0 to many employees.